So when solving questions, it's really important to give an entire solution and not just an answer. So as we look at this first question, we would notice that we are given the speed or the velocity, so that's v. We're given the frequency in hertz, that is f, and in this case we're asked for the wavelength. And so all that points us towards the second equation here. But this is what students often forget. You need to write the equation down. If it's something you're thinking in your head, that pattern, then you need to include it in your solution for it to be a complete solution. So I'm going to write that down, and I'm going to replace any of the values that I know with the numbers that I have. So V is 50, and F is 200, and the thing I don't know is lambda. That's our symbol for wavelength. And then I would go ahead and solve the equation, dividing both sides by 200, and I get 0.25 for lambda. That is measured in meters. Meters is our standard unit, and everything else was given in standard units. The next question asks me to convert that number into centimeters. So one way of setting that up is to go ahead and write my given information, and then I'm going to multiply by a fraction that's actually equivalent to 1. I need to know what's the relationship between centimeters and meters. So there are 100 centimeters in 1 meter based on the prefix centi. So I'm going to put the 1 meter on the bottom so that the meter unit is diagonal from, the 2 meter units are diagonal from each other. And then the quantity I'm changing into will go opposite from that, so 100 centimeters. So the meter part cancels out, and then I just do the math that I see. 0.25 times 100 is 25, divided by 1 is still 25, so 25 centimeters. All right, and the last question asks how far the wave moves. In this case, how far is not the same length as we had before. It's not the 0.25 meters. That's just the length of a single wave. This is actually talking about the wave propagating or moving through space. And so this is asking me to find a distance. This number here is a time. And then I'm going to reuse my velocity value from up above. So I'm going to use the first equation, and again, I'm thinking that equation, therefore I'm writing the equation. V equals d over t. And then I'm going to go ahead and put in my known values. So my speed was 50. My distance is the thing I'm looking for. And then my time is 5.0, and my calculator won't care if that's 5 or 5.0, so I'll just write 5. And then I could think of like cross-multiplying or multiplying both sides of the equation by 5, and I get that my distance is 250 meters. All right, let's look at the problems that were done in class as collaboration questions, a few more examples. So in this case, we have a wave propagating at 48 meters per second. That's our velocity. The wavelength is 1.2 meters. That's our lambda. And we're finding the frequency. So we're going to use the second equation here. V equals F lambda. Again, write the equation. If you're thinking it, you're writing it. And 48 is my V. My frequency is the unknown thing. And then I'm multiplying that times 1.2. I usually put that in parentheses, or you could put a dot or a times. So I divide both sides by 1.2, and I get 40 as my frequency. Now, frequency has kind of an unusual unit. It actually is equal to just per second, but that is usually written as hertz, Hz. Have to get used to that one. And then part B, how long will it take the wave to move 60 meters? How long refers to a time. And this 60 meters is the distance that wave is moving. And so we'll use the first equation here. V is equal to d over t. So I'll put in my velocity that we knew from before, 48, and the distance is known, 60, and my time is not known. So when you see that you have the unknown quantity, the t, in the bottom of a fraction, one method that some people like to use is to cross multiply. So here's one cross, and then I'll think of a 1 down here. Here's my other cross. So I'll take an extra step to make sure I get my algebra correct. And I get 48 times t is equal to 60. And now that it's just, a straight across equation, no fractions, it's a little bit easier to see what to do. I divide both sides by 48, and my time is 1.25. Again, I'm working all in standard units, so that's going to be in seconds. All right, second collaborative question was this. Wave travels 6 meters in 0.75 seconds. So again, that's 6 meters. That is not a wavelength. That's not talking about just how big is a single wave. That's an actual distance that the wave is moving. So that's d. And this is the time that it takes. So I'm going to be thinking of this first equation, v equals d over t. And again, even though it's written right at the top of the paper, I'm going to write it out so that my solution is complete. And then I know my distance, 6, and I know my time, 0.75. And so when I divide 6 by 0.75, I get 8. That is the wave speed for this wave. The wavelength, that's lambda that I'm looking for. Okay, so in order to find lambda, I'm going to have to use this second equation, which means I have to involve the frequency. So now I'll write v equals f times lambda. I'll use this speed that I just found, 8. I'll use the frequency, that's the hertz that was given in the problem, and then times lambda. So I take 8 and I divide by 2.5. And so that comes out to be 3.2. That is my value of lambda. And lambda is a length. It's the length of one wave. So my standard unit would be used here for meters, since everything else is in standard units as well. All right, the last collaboration question, some people got to it, some people didn't. This one has a star next to it, so it's a little bit different. We've got to think a little bit, and it's not just find the formula and put things in. So there are 12 wave crests passing a certain spot every minute. So that's talking about how often waves are passing, how often they must be being created somewhere. And so that refers to a frequency. Frequency is how many waves are being created per time. We don't really have an official formula for that, but that's the idea of what a frequency is, the waves per time, the number of oscillations per time. And so this is given to us, we could fill things in right away, but it would be in per minutes, and we want per seconds. So since it's 1 minute, and 1 minute is the same as 60 seconds, I'm going to use that 60 seconds as my time. So my frequency is 12 waves per 60 seconds. And when you divide that out, you get 0.2, and that per seconds is what we would call hertz. All right, so now I have a frequency number to work with. The wave crests are 15 meters apart. Okay, so that means that if I drew a wave, that this distance here is the 15 meters. Well, that is the wavelength. That's one wave. And so we're going to use this equation here, v is equal to f times lambda. So we would take the frequency that we just found, 0.2, and we would multiply it by the 15, which is the wavelength. And so 0.2 times 15 is 3. That's our wave speed.